Hello all, welcome to week 7. The first thing that we will do this week, I'll help you to go through the assignment that was uploaded for week 6 and then help you to solve that assignment. If you remember what that assignment was, week 6 we finished logic coverage criteria. Specifically, we saw how logic coverage criteria applies to test source code, to test design aspects, things like preconditions or postconditions or invariants that come with design. And we also saw an example of how logical predicate come as guards in finite state machines and saw how to design test cases based on that. So I've given you a simple assignment for 10 marks consisting of fill in the blanks and objective choice questions for that week. This video will walk you through the assignment and we'll discuss how you could solve it. I hope all of you have made an attempt to solve the assignment yourself before viewing this video. So what was the first question in the assignment? It was a problem of reachability and controllability, or RIPR criteria as we called it in the first week. So some predicates in source code purely contain internal variables, may not contain any inputs. So I need to be able to reach those predicates and effect whatever coverage criteria that I want to effect on them by changing values of inputs. Right, so this question is about that. It asks you the problem of reaching a particular statement containing a predicate with internal variables and assigning values to inputs such that the predicate can be made true or false. A particular clause in the predicate can be made true or false. What is this problem called? It is the problem of controllability. It comes after the problem of reachability. Reachability will just reach the predicate. Controllability will help you to assign values to input variables so as to control the predicate. The second question was a simple state true or false question. It asks, consider a predicate that has only one clause. It asks you to say, is clause coverage the same as predicate coverage is the same as combinatorial coverage? So the answer to this question is an obvious yes or true. Why? Because the predicate has only one clause, so making the predicate true or false will also make the clause true or false, and there are exactly two possible assignments for this single predicate that contains a single clause. That's the entire truth table. The single predicate is made true once, single predicate is made false once. So the truth table also has exactly only two values. So it's the same as all combinations coverage. So whenever a predicate has a single clause, all these three coverage criteria, predicate coverage, clause coverage, and all combinations coverage turn out to be the same. Question number 3 was a multiple choice question. It reads as follows. It asks you the following. Which of the following represents the normal form in which predicates corresponding to preconditions are? There were 4 options given to you in the question. The option 1 was pre-next normal form. Option 2 was disjunctive normal form. Option 3 was conjunctive normal form. And option 4 says it occurs in a normal form that's none of the above 3. The correct answer to this is the third option, which is conjunctive normal form. Why is that so? If you remember, when we had seen predicate conditions, we had seen an example relating to days. The example program that we had seen was calculate the number of days between two given dates within a same year, and then the program had several preconditions which specified what the values for months will be like, what the values for the various dates will be like, and the fact that the value for the first month should be before the value for the second month so that I can specify the number of days that have passed in between the first date and second date. We had taken all these preconditions, and in the program the preconditions that were written in English originally were transformed into predicates. Each condition was written as a simple clause, and the entire precondition corresponding to the program was an AND of all these individual clauses. So if it's an AND of all the individual clauses, or if it's an AND of what is called disjuncts, where inside there are ORs, then the normal form is supposed to be conjunctive normal form, because conjunct represents AND, and this entire predicate which occurs as a precondition is an AND of all the individual conditions. Because we really cannot write an OR because you can't say that one of the preconditions should be true. It says each and every single precondition should be true. So the natural connective is an and. When the connective is an and, the normal form that we are talking about is conjunctive normal form. Disjunctive normal form deals with ors. Pre-next normal form, in fact, doesn't deal with this kind of thing. It deals with formulas which have quantifiers. I just given it as a filler option. So the correct option here is conjunctive normal form. So the next question is, it asks you to state whether a given statement is true or false. The statement that was given is clause coverage for predicates that model specifications always feasible. In other words, when we consider specifications, which are requirements given in English or as finite state machines, write out the logical formulae corresponding to them and consider clause coverage for these predicates. It asks, is it always possible to write test cases for the TR of clause coverage, or in other words, is clause coverage feasible? The answer is false. Why is it false? We saw an example through the course of lectures last week. If you remember, we saw the example of a finite state machine corresponding to a subway train, and there, using illustrations, I showed you how if one clause becomes true, then the other one cannot be true. So two clauses in a particular predicate cannot be true simultaneously. So if I have to consider clause coverage, I have to be able to make each clause in turn true and false. But they occur in such a way that if one clause is true, the other will never be true. So if I try to achieve clause coverage for one clause, I will not be able to achieve clause coverage for the other clause. So clause coverage for predicates that occur as specifications are not always feasible. So the answer to this question is false. For the remaining 6 questions, that is question number 5 to question number 10, I had given the state machine that we saw during the lectures, which was the state machine corresponding to a subway train, and I had asked you to work out a few things related to predicate coverage for that state machine. So the state machine has 4 states. Just to recap, these are the 4 states: all doors closed, all doors are open, the doors on the left hand side are open, and the doors on the right hand side are open. Initially in the train, the initial state as marked like this is the state where all doors are closed, and the train starts moving out of the station. When it reaches the next station, if the platform is on the left hand side, then the left doors become open. When the platform is on the right hand side, the right doors become open. In case there is platform that is accessible on both the sides, then all the doors become open. So what are these predicates that model the transitions between the states? So it says from the state all doors closed to the state left door open, I can do the transition provided this fairly big predicate is true. So let's read the predicate and understand what it says. So it says train speed is 0, which means the train is not moving. It's come to a station. If train is moving, you better not open the doors, right? And it says the platform is on the left hand side. That's what I told you a little while ago. Location, either the train is in the station, which says location is in station, or somebody has pressed an emergency stop button, that's why the train is not moving, and has also done an override open of the train while the train is still in the tunnel. Is it clear, please? Similarly, on the other side, I'm sorry, this guard is running over a bit out of the slide, but it's an exact flip of the guard on the left hand side. So you say from a state where all doors are closed, I can move to a state where the right door is open, provided the train is not moving, platform is on the right, and the train is in the station, or somebody has pressed an emergency stop, done an override open for the door, and the train is still in the tunnel. If from any of these states, the other door is open, the platform is available on the other side, like if the right doors are open and the second platform is available on the left hand side, then you can open the left door, so you go to state all doors. Similarly, if the left doors are open and the second platform is available on the right hand side, then you can open the right doors also, and then you go to the state all doors open. So from the state all doors open, I can go to all doors closed, provided there is no emergency stop, nobody has pressed override open, all the doors have been cleared in the sense that there are no passengers moving in and out of the doors, and somebody has pressed the close door button. So is it clear, please, what the state machine looks like? So this is a simple 4-state state machine studded with a lot of predicates. So we'll see some questions about the state machine and about predicate logic coverage criteria. So the fifth question, which was the first in the list of questions about the state machine, reads as follows. It says, for the finite state machine to be in a state corresponding to all the doors being open, the platform should be on the left hand side and on the right hand side. Is the answer true or false? The answer is obviously true, because if you inspect this finite state machine, as we saw, it could be in left doors open or right doors open, and if the platform is available on the other side, then it goes to all doors open. So the answer to this is true. So the next question says, manually inspect the FSM, which means study the FSM, and state true or false for the following question. It is possible to go from all doors open state to all doors closed state when there is an emergency stop. So let's go back and inspect the Turing machine. The state that we are considering for transition from, out of, is the state all doors open. The state that we are considering to transition into is the state all doors closed. And the question says, I can go from this state to this state when there is an emergency stop. So let's look at the guard in that transition. There is an emergency stop clause in the guard in that transition, but what does the clause come with? It comes with a negation. If you look at it here, the first clause is the clause on emergency stop. It says negation of emergency stop, not emergency stop. So the answer to this question is false. So moving on, the next question, question number 7 in the assignment was the following. Can the finite state machine model be in a state such that the train is not in the station and not in the tunnel? Is that possible? If you remember, we had looked at it even when we did the lectures. It is possible. So when you try to do the truth table for each of the clauses, you will realize that there is a particular state where the not tunnel, in tunnel need not be true and in station need not be true. Whereas in real life, that's not possible. And in fact, when we did the lectures, we had understood that there is something wrong with a finite state machine. So from the point of view of testing, it should be flagged as a potential error or vulnerability back to the designer. So the next question was about clauses in a predicate determining the predicate. So we started with one guard, which is the guard that takes you from all doors closed to left doors open, which was this guard. It says train speed 0, platform is on the left hand side, train is in station, or there's an emergency stop, an override button pressed, and the train is still in tunnel. If you see, there are 6 guards here, 6 clauses, here. 1, 2, 3, 4, 5, 6. And what it asks you to do is we've taken examples of 3 clauses and asks you to determine the condition about when the clause will determine the predicate. So in this question, we've taken the first clause, which is the clause of train speed being equal to 0. And you're asked to determine when this clause will determine the predicate. I have not given you the working out here, but the kind of thing that you have to do is substitute for this clause to be true in this whole predicate, substitute for this clause to be false in the whole predicate, and XOR it. Then use the logical operators that we know, inference rule that we know, to be able to simplify it. So when I substitute it with true, it will be true and something else. So the true will go away. This one will get retained. When I substitute it with false, it will be false and something else. So the false will stay back. And then you go on simplifying. This will be the final answer. It will be platform is equal to left and location in station, or emergency stop and override open and location in tunnel. This is what will happen. This is the predicate that we will get if we try to make the first clause determine the guard. So you stop at this. You don't have to write test requirements or test cases for CACC and other active clause coverage criteria. I just ask you to tell the conditions or the predicate under which this clause will determine the predicate. That's all it's a question about. Next question is very similar. Instead of it takes the same predicate and it takes this clause, override open, which comes inside this and asks you to determine the conditions under which this clause will determine the predicate. So you have to do the same thing, substitute override open with true ones, substitute override open with false ones, and then simplify the resulting logical formulae using the inference rules of logic and write the final predicate, which will tell you exactly when this clause will determine the predicate. Here again, you don't write the test cases because there is no TR given in terms of do this to achieve certain active clause coverage criteria or inactive clause coverage criteria. So you just stop at writing the resulting predicate and leave it. Question number 10 is again the same thing. It picks up another clause. This time the clause that's picked up is the clause which says platform is on the left, and it asks you to determine the conditions or the predicate under which the clause determines the guard. Do the same thing, substitute this to be true ones, substitute this to be false one, XOR them, use the inference rules of logic to be able to simplify it. This is the resulting answer that you will get. Try and do it on your own. If you get stuck, feel free to query me in the forum and I'll try to work it out for you through a reply. I hope this small assignment solving exercise was useful for you and your answers did match a lot with the answers that we have worked out today. What we will do today for the rest of this week is I will start with a new chapter which is called input space partitioning. So my next lecture, we will not do logic coverage criteria anymore. We will begin with a new set of test case algorithms based on input space partitioning. Thank you.